Hello everyone, the storm is starting. I am Alextrocute. That's not the normal intro that I use for vlogs, but anyway, I have a couple things to talk about. First one, very self-explanatory. When I was recording episode 5 of the Roblox game, the battery on the camera ran out, and even though I think I recorded everything that I had done up to that point, I thought I might have lost footage, so I deleted it, even though that might have not have been necessary, but that's already over and done with. I'm not sure if I'm going to be able to get that back or whatever. I think they could have seen me much. Anyway, that's not the only thing that I wanted to talk about. Because I'm weird and I'm interested in this kind of stuff, I looked up all of the different fundamental particles that we know that are in existence and ones that we think might be in existence. The first ones that we're going to be starting with is quarks, which some of them have fractional charges, which is super weird since you wouldn't think that would be a thing, but it sort of makes sense if you actually look at what they make up and stuff like that. You start with the up quarks, which have a positive 2/3 charge. Yeah, fractional charges, like I just said. And down quarks have negative 1/3 charge. Yeah.
You say so.
Yeah, protons are made up of 2 up quarks and 1 down quark. Yeah. 2/3 times 2 is 4/3 minus 1/3 of the down quark is 3/3, which is 1, giving the proton a charge of +1. It's pretty simple maths. And neutrons, which are also in atoms, are made up of 1 up quark and 2 down quarks. An up quark is obviously 2/3 positive, and each down quark is a negative 1/3, so a neutron is neutral. It has no charge. Electrons are actually... Dang it, I didn't put down a label for those. I have quarks, leptons, and I think these are... Yeah, those are bosons, even though I don't know why they're called... Well... Yeah, that makes sense to call those bosons. That's what they're called anyway, bosons. But anyway, there are 6 different types of quarks. Which include, of course, up and down quarks, which are named not because of their charge, because that wouldn't make any sense, but apparently because of their spin, whatever the heck that means. There are also strange quarks, which are called strange because of the fact that they were apparently observed in radioactive elements that were decaying slower than what they should have been. Not sure if that's really a reason to call it strange, and I think I heard from SciShow there's some sort of quality in quarks called strangeness, and I'm just like, no. Science, you've gone too far. Do not start calling things you don't understand strangeness. And the dog. Anyway, there are also charm quarks. I don't even know what that means. And top quarks and bottom quarks, which were named to be basically the same as up and down quarks, but different. And I have no idea what any of those 4 quarks do. I'm not even sure if anybody knows them. They might have been just seen in a lab, like some of the more recent elements. Like, they have up to 118 elements that have technically been observed for like less than a millisecond, so yeah. Up to 118. Good job. Anyway, those were all of the quarks, obviously. And now let's move on to the leptons. I'm not sure if well, I guess you're not going far. You're just doing that. Anyway, leptons. Leptons include electrons, which have a -1 charge, even though they only have 1/2000th of the mass of a proton. They have a -1 charge. And I don't even know what the exact weights for each of the quarks are, not even the up and down quarks, but I guess you might be able to calculate it out knowing what type of quarks make up which things, neutrons and protons, but I'm not going to do that in this video. And there's also muons, and yeah, muons.
Who made this up?
I don't know, some scientist somewhere.
They're strange, they're charmed, they're leprechauns, they're cattle moo.
The video that I watched literally said that the charm quarks, who are named charm quarks, simply because the people observing them thought that they were cool. And they were interesting.
Assigning personalities to those building blocks is kind of...
Yeah. In total, by the way, I think there are like 12 plus 5, 17 fundamental particles that we've proven. Yeah. And there are 3 particles that we've speculated about, but we don't have any proof of. But let's continue on with the leptons.
The leprechauns?
They're called leptons. And I know that they probably got these names from somewhere. I know quarks came from somewhere because they originally thought there were only going to be 3 different types of quarks, so they got a quote from some book somewhere that said something about the number 3 and then ended the sentence with the word quarks, whatever they were trying to use that for. So they decided to name it quarks. Because that makes sense.
Sounds like a crystal rock.
Quartz. Yeah. And let's continue on with the leptons. There are also tau particles. Yeah, that's about what I expected. Yeah. And also a part of the leptons, each of the electrons, muons, and tau particles, well, there aren't multiple different types of those, but I literally just said that wrong. There are 2 different types of electrons, muons, and tau particles. There are the normal ones and the ones that are apparently neutrinos for some reason. You just say electron neutrino, muon neutrino, tau neutrino. Because apparently adding neutrino makes it far different than the normal one. Because everybody knows what a neutrino is. Exactly. Now let's move on to the bosons. One of them you might be familiar with is photons, as you would obviously know is light, which are, I need to say something confusing to confuse you and everybody watching. Photons aren't just particles per se, but they're also waves, so they're called wave-particle dualities. Yeah, wave-particle dualities.
Alternate universe?
No.
No?
I'll kind of talk about waves a bit more. The wave is kind of dependent on how much energy it has. Like, the wavelength becomes shorter and more red until it eventually gets into the, I don't, no, it's not ultraviolet, is it UV? No. Whatever it is past red, you kind of know what I'm talking about. It's up there with, like, microwaves and gamma rays. Things with extremely small wavelengths and high energies that can literally knock electrons out of atoms, which is why they cause cancer.
Radioactive?
Yeah.
Radio waves?
Radioactivity, what atoms do is that when they're super radioactive, their electrons in the atom have so much energy that they can spontaneously, and as scientists know so far, randomly their electrons drop down to lower energy levels, and in doing so they create photons with high energy in them. And those photons can basically fly out at the speed of light and do just about anything. Okay. And of course, ones with lower wavelengths are called ultraviolet, radio waves, and all that kind of stuff. They have really low energy. Why did that make you laugh?
Give them some coffee. Or a Red Bull.
Yeah, because what we need is higher energy particles that can cause cancer.
Right.
Yeah.
I'm sure that if you look good at the damaging cells in the body.
Yeah, I should put this on just so I look like a scientist.
Oh, okay.
Because my channel hasn't been random enough recently. Yeah. And how about I grab this to make me look like a mathematician too? Yeah. That. Okay. There are also Z bosons and Y bosons.
Why? Why are there?
I don't know. I have no idea why those exist.
Somebody thought that would be clever.
I don't know. A, B, C, D, E, F, G bosons.
Okay.
Yeah. Gluons.
You're kidding me.
No. And it makes sense, too, because I think I remember that those particles is what allows the up and down quarks to bind together to make protons and neutrons in the first place.
Of course.
Why do you think they called it a gluon?
Because they didn't want to call it a slimon? Or ectoplasmon?
That sounds like a Pokemon, Ectoplasmon.
Ghostbusters.
The new movie isn't good, though.
Oh well.
Everybody knows that.
Maybe that's why I haven't seen it.
Yeah, don't. Anyway, now, finally, the final one, particle that we actually know about, is the Higgs boson.
Oh yeah, Higgs boson, yeah.
Do you
The
have...
God particle?
Well,
No?
it's what people used to consider the God particle, but now people have a different idea of what it is, because God particles can't exist. You can only
Right.
make them up, right?
Right.
Once you
You
find
can't-
it, you have to think of something else that's far more awesome.
Right, there
Because
is no God, right? I mean,
yeah, there's
that's
definitely no
you
God.
can't believe in science and God at the same time.
Believing in the multiverse is definitely less based on faith than religion. I mean, come on. And believing that in the even with the omnidillions amounts of planets that there are, I'm not even sure if that's a number. The percentage chance of life as we know it anyway, at least that we would understand it happening, even though we might be able to find things like silicon life, but we have no proof of that. Would we even be able to recognize it if we saw it? I don't know. You know, on the periodic table, it's like carbon, and then you go down one slot, and then it's number 14 silicon. Basically, that and everything below are technically elements that have a chance to support life because they have 4 extra electrons, which means that they're super radioactive. Well, not radioactive, but they're super reactive because atoms want to have 8 electrons in their rings or get rid of the ring of electrons entirely. So if they have 4, they either need to get rid of 4 or add 4, which gives them a lot more radioactivity than anything else. But anyway, silicon and carbon are the best candidates. But anyway, like I was trying to say, scientists have pretty much concluded that even with the insane amount of planets that could potentially exist in our universe. By the way, scientists have concluded that if the Big Bang was a real thing, and thank you for hitting the camera, trying to hit the dog.
I'm trying to get him away from me.
Then just, I don't know, do something else. Anyway. Anyway, like I was trying to say, scientists have assumed that if the Big Bang was a real thing, which, I mean, how could the Big Bang have happened if there was absolutely nothing before that we could possibly explain with science? Anyway, even with the observable universe being as big as a light bulb, if you calculated the size of the entire universe, the observable universe would be the size of a light bulb in comparison to Pluto. Observable universe, light bulb, Pluto, planet. The light bulb is the observable universe, Pluto is the universe we can't see. Even with all of those planets and all of those possible places of existence, antimatter, all of that stuff we have no idea about, which I will be talking about. The number of possible planets with life has dropped to only a few thousand out of all of those, and it still keeps falling because we've realized exactly how many criteria for life that we know it to exist is getting more and more. Right now we have like, I think 100 different criteria that need to be perfectly met for life to exist on a planet. It's not as simple as having the right elements and being in the right place of a star. It's not that simple. Especially complex life. And you want to know the other thing? The chance of the universe existing at all is insanely small because of the fact that if the strong, weak nuclear forces, which I should probably make a video about because I don't have it on the paper, the size of the atom, different charges of particles, interactions between particles at all, were even the slightest bit different, certain particles wouldn't be able to form, certain things wouldn't be able to happen. Nothing would really exist. you know?
Hmm.
You could say that all of this just happened by chance, but that's,
It was an accident.
yeah, it's not really. How small of a chance can it be for you to still believe in it? I mean, scientists have said one thing, I do believe, since they've been coming up with all of this quantum theories and stuff, they've decided that electrons are a real thing, but you can't exactly predict one's location, so you have to kind of put an electron cloud around the atom to label for the percentage chance of where it might be at any certain time. And as you get farther away from the atom, it still never reaches zero, so technically an atom right here could have an electron on the entire other side of the universe. Yeah. I think I was going to say something else, wasn't I? For that. I know I'm looking at you a lot. I'm not trying to put you on the spot or anything, but you seem to be very interested in what I'm saying. Right?
Yeah, it's been over my head. It's like I thought science was so precise and stuff. It sounds pretty vague to me.
Well, science can't do as much observation with things as small as what we're talking about. Because when you think of an atom, you think of some super small thing, right? Like, think of this room. Think of this room as the size of your fist, and then fill this room with grains of rice. Those grains of rice are the size of a cell. Now you take that grain of rice, expand it up to the size of the room again, or for perspective, expand each grain of rice up to the size of this room. Now fill each grain of rice that is the size of a room, with even more grains of rice, and that's about the size of an atom. And atoms are 99.99999% empty space. And those things, except for the electrons, are made up of other things. Protons and neutrons are made out of quarks, for example. And gluons. Is it fun yet? Yeah, I was probably going to talk about something else, but yeah, I kind of forgot a while ago, but I think I'm being crazy enough, so it's good enough for me.
That's theoretically out of my brain.
You want to know one of the things that people have been speculating on for a while? We've obviously observed gravitational waves, because even if you wanted to measure a gravitational wave, like, let's say it had a ruler right here and a gravitational wave went past, a gravitational wave is literally a bending in space, so you can't exactly measure it in terms of distance. But if you fire a photon, which moves at the speed of light, obviously, and a gravitational wave passes by when the photon is moving, the photon will either arrive quicker or slower than the speed of light says that it should, because it's literally a bending in space. This point here is now closer to this point because it's a bending of space, a bending of distance. Which is technically a way to get around the speed of light if you could technically make a ship that was good enough to be able to exploit that to go faster than the speed of light. But the thing is, people are mainly thinking about wormholes. And guess what would happen if I made a wormhole right there, the size of a door, and a wormhole exit there that was the size of a door? nuclear explosion.
Oh, great.
Because even though it might seem sane to think of a door going there and coming out of there because we see that so much in fiction, you never really think about the atoms on the edge of the door now, do you? What happens to those atoms? Well, they're crunched so much together that they instantly start nuclear fusion and explode. And the other thing with wormholes is that for them to function and, not be smaller than an electron, you have to have less matter inside of them than what is actually zero, if that makes any sense. Let's say I had a wormhole right here. It has 1,000 mass in it. You take out the 1,000 mass, there's literally nothing in there. You have to have less than 1,000. Less than 0. You have to take out more than 1,000 of the percent, 1,000 of the mass that was in there for it to function. So, what do you think you would do to get it below 0 things inside of it?
Turn into black hole.
Well, no. You put in negative mass. Because that's technically a thing. It doesn't break the laws of the universe because of the fact that technically mass is conserved. If you create a particle with 1 mass here, you can technically create a particle with -1 mass here. As long as you create the same amount of positive mass as you do negative mass, you can, as long as you find a way to, create an infinite amount of each. You'd need about the size of a moon of negative mass to keep a portal of that size open, though, per second. So I don't think it would work out very well.
I don't think we're anywhere near
Huh?
that kind of technology.
The kind of weird thing is, though, is that people started speculating that there was a gravity particle, and that never really worked out. I don't even know what a gravity particle is or would do, but I guess they kind of speculated it because of gravitational waves, because those exist, but, whatever. I'm looking a little concerned. Yeah, God particle, which they say would either end all of the universe by changing the different physics of the universe, how things interact or whatever, or, you wanna know what, let's not even talk about that one. It's completely speculative and it doesn't really make any sense, it's just so hyperbolic an idea. Like, I can create a particle that can destroy, create, or do anything. I'm gonna be awesome when I find it, because definitely everything that we think's gonna be here is going to be there. Anyway, dark matter and dark energy. It is not the same thing as antimatter, by the way, which, antimatter is made of antiprotons and anti-electrons, because those exist. Anti-electrons have a positive charge and antiprotons have a negative charge. So they work the exact same way as atoms do, but just flipped around. The thing is, if positive and negative matter come in contact, it just explodes. So don't do that. But the antimatter is different from dark matter, which has a positive mass. It doesn't interact with light, but yet it's pretty much everywhere. It's kind of the thing that holds galaxies together, because normally, even with supermassive black holes, it wouldn't have enough mass in the area outside of it to actually keep a structure that big together. Does any of that make sense? Okay. That's fine. And I also kind of wanted to make this video talking about this amount of subscribers that I have now. Guess how many it is? 10.
Really?
Yes, I have 10 now.
Whoa.
I was only able to get 9 names though, which was a bit of a shame. I really hoped that I would be able to get exactly everybody, but I missed one person, and obviously if you're the one person watching this that has subscribed to me that I didn't put on this list, please let me know. I don't want to just completely forget about you in the long run, but this was literally everybody that I could possibly think of, or that I know has subscribed to me. Okay. Explode. It's like explosion plus loading with the capital XPLOSIE, load. Yeah. I guess it's just pronounced explode. I'm not sure if that's Lashile or Ishile. It's either I or L S A N E I. I'm so bad with names, honestly. Christina, Christina. Yeah, I'm looking at you, but I don't know why.
Well, I can't see it, so I don't know.
Scar. It looks like it's supposed to say Scar Lord, but it has an LXRD. And 2 A's. So, yeah. I know that he subscribed to me. I got a notification from him, and I think it was just yesterday, Christine. Yeah, I can't pronounce that. I'm very bad with names, but I got notification from that person yesterday, I think, which brought me up to 10. The rest of the people that I can think of are Cinder Snivy, aka Josh, Dr. No One, aka Colby. Of course, you subscribed to me so you could watch my videos at work. My dad subscribed to me, so I guess just because. I think Mr. Beeson, one of my teachers from last year, subscribed to me, or was it freshman year? I don't remember, but I think he subscribed to me. Probably doesn't watch any of my videos just because I brought it up to him, and then I really didn't make anything for so long. Yeah, it doesn't really matter if he's forgot about me, it's fine. Mr. Fishback, I brought my channel up to him, I think it was just a week ago, and he was really excited. Do you remember him from last year?
Mm-hmm.
Yeah, he was really excited to start watching.
Cool.
He might be watching this video right now for all we know.
Maybe.
Well, technically not right now, but
Yeah.
you obviously
After
know what I
you-
mean.
Yeah. Once it's published.
Huh?
Once it's published.
Yeah, once it's published. I was originally hoping to get more videos out today, and I still might. But that's kind of the story of my life recently.
Oh.
well, at least the past couple of days. I wanted to get more videos out yesterday. I wanted to get more videos out the day before that.
Well, you have a job. It's being a student, so, you know.
Well, I don't consider it to be a job if you're not getting paid. It's more of just learning and getting experience.
It's work.
Yeah, it's work. And I'm technically getting job experience from doing yearbook, but you could really call it more of an internship than anything because, like I said, I'm not getting paid for that, even though it's
kind of
literally kind of a work setting,
right.
And I had to sign a contract and all that. Is that everybody that I have here? I think that's just about everybody. It's 9 people.
Cool.
I'm pretty sure. Wait, is that 9? 1, 2, 3, 4, 5, 6. No, that is 10 people.
Okay.
Yes, I guess I got that right. That's cool.
Mm-hmm.
I didn't actually forget anybody. I just forgot to put a bullet point here so I could actually see the damn thing. I was going to ask you if you possibly remembered anybody else, but you wouldn't really know, probably. But anyway, that's pretty cool. Got absolutely everybody that I know and think has subscribed. Because I only see actually 3 people in my subscription list because you can either have it public or private subscriptions. So people can see you or not see you.
Oh, okay.
Yeah, that's kind of important.
Privacy thing, that's cool.
Yeah, but it does give you a notification whether or not you have it on or not. But they just can't permanently see you in their list. They just see, oh, the person subscribed, it'll show you who did, but you can't get that information forever. So I might need to keep a list, at least as long as I stay a small channel and I can actually keep up with that kind of thing. But that's kind of just a dream. I think that's the end of this episode of the vlog. I think it's vlog number 5. What might you be doing there? Looking at the names there? I'm trying to figure out how to pronounce them or something.
I don't have a clue.
Yeah. Okay, but yeah. That's good enough for now. So, storm is ending. I am Alextrocute. If there's anything that you want me to draw, make a series on, do in one of these vlogs or whatever, just let me know down in the comments. Like I said, storm is ending. I am Alextrocute. And goodbye. Hope you enjoyed the video.